Hello everyone. So today we are going to see what is a simple linear regression and some of the key concepts associated with this machine learning algorithm. So as you can see, it is called simple because there are just two variables and it is trying to find the relationship between these two variables. So there are some important concepts that you should know. First is the coefficients, mean squared error and coefficient of determination. But before that, let us look at this chart here. So this blue line is nothing but your model, which the machine learning model has created. And these blue points are actually your true values. So there is obviously this distance, right? There is these values are not as per the predicted values of the model, and there is some variation. So, how does the model determine that this should be the model line, not this line or this line? So, how does the linear regression determine that how this is the best fit line? So, that is the concept of ordinary least squares method. So, now let us see what is happening in the ordinary least squares method. So, as you can see, right, there is a difference between your predicted value from the model and your actual values. So, what the algorithm will do is find this distance and square the distance, and then it will do a sum. So, it will do a mean of the squared values. And then, wherever this summation or the mean of the summation is least, that will be used as the model. So say suppose this line has been created by the model, it will create a what is the uh, sum of the squares of the mean value. There will be another line, it will create the summation of the mean errors, and then whichever line is giving the least error, it will pick that line. Okay, so that is why this method is also known as the ordinary least squares. Okay, now let us look at some of the key terms that are used in regression. So as you can see, this is the intercept or the constant here, and this is the model line, and the slope of this line is known as the beta 1, and beta 1 is the coefficient, and that is what we are interested to find in regression. And here you can also see this is the correlation coefficient. So this is the correlation coefficient, but this is the coefficient. So what is the difference between this and this? Or in other terms, what is the difference between correlation and regression? So correlation will give you the strength and direction of the relationship, how the two variables are moving in relationship to each other. If x is increasing, y is increasing, x is increasing, y is decreasing. So these relationships, the correlation coefficient will give. But if we have to find the impact of change of one variable to the other variable, that is given by regression, and that is given by the coefficient beta 1. Now, let us see what other concepts are there. So, we looked at the coefficients, we looked at the mean of the squared error. Now, let us look at the coefficient of determination. Coefficient of determination is also called the R square. Okay. So it is a very important concept to understand. And let me pick one of the interesting articles that I found, which is posted in LinkedIn, and I highly encourage everyone to read it. So I'm not going to explain in very much detail, but the concept is something like this. So say suppose uh, we are trying to determine what is the relationship between age and income. Okay, so income is there. Say we don't have any model, we don't know any modeling concept, then if somebody asks what is the average income. So that is this average income by bar. Okay. But now when we have this model and we are applying some correlations and we are trying to find the relationships, then we have this model line. Okay. And then we also have uh, the yeah, sorry, we have this model line and this average line. Okay. And then we have these points. Okay. The actual points. So when we try to find this distance, okay, this is your true value and this is your predicted value, and this is your true value and this is your mean value. Okay, you see how this true value is very far from the mean value as compared to your line of best fit. We don't have the accurate result, we don't have accurate predictions, but anyhow it is better as compared to the mean value, right? So that is what the fundamental concept of r square is. R square tells you the explainability of the model, how the variation in your independent, or how much of a variation in your income is being explained by your age or your independent variable. Okay. Otherwise, uh, if so, for example, r square. Okay. If r square is 1, it means that your model is doing a very good job in explaining the variation. But if r square is 0, it tells you that, hey, your model is not good. It is as good as doing an average and finding an average value. Okay. So that was in a nutshell to explain you the key concepts. Uh, I wanted to briefly touch upon some assumptions also. So, for example, uh, as you see that we are trying to draw an approximate line. So, what if your data is having a lot of outliers? You know, then this will not give you correct uh, predictions, right? The slope will get affected and it will not be good. The other assumption is definitely that there should be some linear relationship, and that we can check from the correlation coefficient. Okay, so these are some of the assumptions, and I think uh, I just touched upon some of the key concepts, and I highly encourage that there's so much literature available, and you can spend some time reading that. So now let us see one practical demonstration of uh, a simple linear regression. So see you in the next video.